A special type of factoring is called difference of perfect squares, referred to as DOPS or DOPS for short. So it's exactly what it says, difference of perfect squares. Difference means we're subtracting perfect squares. So an example of that is if I give you x squared, that's a perfect square because x times x is x squared, and then say minus 9. That is difference of perfect squares. Now the idea is how do we factor that? Well, if we look at x squared, if that factors, we know that's going to be x times x to give us x squared. And notice that there's no GCF here. We can't divide by the same number or variable. So if it factors, it's going to be this 2 pair of parentheses. So x times x is x squared. And then what multiplies to negative 9 and adds to 0? And the reason I'm saying that is, notice that the x term, x to the first, is missing. So this is really x squared plus 0x's minus 9. So this will be the standard form, writing a, b, and c values in that form. So that middle term is really a 0x. So what multiplies to negative 9 and adds to 0? Well, positive 3 times negative 3 will do it. And if you FOIL this back out just to make sure that it works, x times x is x squared, and then x times negative 3 is negative 3x, and then 3 times x is positive 3x, and then 3 times negative 3 is minus 9. So notice what happens is those middle terms will add to 0, and you're left with x squared minus 9. So again, that's what we call difference of perfect squares. Now this is a very basic case of it, x squared minus 9. You could also have x squared minus 16, which will be x minus 4, x plus 4. Notice the form is going to be one of the terms is positive and the other is negative. A more convoluted example is suppose we had, say, 4x squared minus 25, so something like that. So here, there's no GCF, so 4 doesn't go into 25, and x squared, there's no x over here that you can use a GCF for. So if it factors, it's going to be 2 parentheses, or 2 pair of parentheses. So let's look at this. What can we multiply to get 4x squared? Well, what do you multiply by itself? Is 2x times 2x. Now, what multiplies to get negative 25? That'll add to 0 in the middle. We know that plus 5 and minus 5 will work. Now, this is a little different because it may be confusing because of that 4 in front of the x squared. And you may think, well, gee, that's not going to work out at all. But let's see what happens. First terms, 2x times 2x is the 4x squared. So that's good. The next term, 2x times negative 5 is negative 10x. And then we have positive 5 times 2x is positive 10x. They're going to cancel out. And then 5 times negative 5 is minus 25. So notice we end up with 4x squared minus 25. And just to do one more kind of example here with you, suppose we have something like 49 minus 16 x squared, something like that. So here, the first term is 49, the second term is minus 16x squared. So is that difference of perfect squares? Well, what do you multiply by itself to get 49? 7 times 7. And then what about the 16x squared? Notice here, the 16x squared, that is coming second in our terms, but the form is still the same as difference of perfect squares. So how do you multiply to get that first term of 49? Is 7 times 7. That gives us 49. Now, what multiplies to get negative 16x squared? positive 4x times negative 4x. And if we check it out, 7 times 7 is 49. And then 7 times negative 4x is minus 28x. Inner terms, 4x times 7 is positive 28x. Notice they're going to cancel out to 0 or add to 0. And then 4x times negative 4x is negative 16x squared. So that actually works as difference of perfect squares. Okay, what you got to be careful of is you can't just rearrange that to 16x squared minus 49. That's not the same thing. It matters which term is negative. So you got to be careful with that. So that is the difference of perfect squares method.